Okay, so we've got a question here on statistics. We want to find the mean and variance with this PDF here, this probability density function. And we're given it as x squared over a over the support of 0 to 3. That means our random variable x is somewhere between 0 and 3. And this is a continuous function. So this is not a definite value for the x, it's a continuous. Okay, so when it's in this form here, we've got x squared is our density core and our a here is our normalising constant. So how are we going to make a way of showing that this is a valid PDF? Well, the first one is by integration. So for a valid PDF, so I'll just write this here, for a valid PDF, probability density function, what we need to do is show that this integral here, I'll just write PDF here, integrated with regards to x equals 1. That's the main way we can show this. So we can update this. The range of our function is from 0 to 3 and our PDF is x squared over a. So if you can plug that into there, we should be able to work out some integral to find out this normalising constant. So from 0 to 3, that's our support. PDF is x squared over a, and then integrate with regards to x to equal 1. Okay, now the a, when we integrate this, is not part of the x, so we can bring this out. So 1 over a, and then the integral from 0 to 3 just leaves us with the x squared now, and then dx equals 1. Okay, let's take those full stops off, they're confusing. Okay, so now we've got a straightforward integral here now. Power rule, increase the power by 1, divide by the new power. So let's just go ahead with that. So 1 over a, x cubed over 3, from 0 to 3, and get that to equal 1. Okay, let's plug in the values of x. Plug that in, 1 over a. When x is 3, we've got 27. And when x is 0, we've got 0. So that equals 1. So 27 over 3 is 9. So now we've got 9 over a equals 1. Though the only way we can get that correct is if a equals 9. So our normalising constant now we know is 9. So we just update this here now. PDF x squared over 9. Right, okay, that's the first stage of the question complete. So now what we need to do is to find the mean. Now the mean we can do by way of integration again. So e of x, so integrate that over the support, 0 to 3. And then in the brackets here, whatever we've got in here, so x is the first moment, so it's x. If it was x cubed, we'd write x cubed here. So e of x is just x multiplied by our PDF. So multiply that by x squared over 9 with regards to x. Okay, let's go for that. So now we've got 0 to 3, x times x squared over 9, so that's x cubed. And we can bring the 9 outside and then dx. Now we just simply integrate this x cubed. Again, power rule as we did before, not forgetting the 1/9. So now we've got x to the 4 over 4. So increase the power by 1, divide by new power. And again, 0 to 3. Right, so now we plug in our values for our x, 3 and 0. So we've got 1 over 9, x to the 4 when x is 3 gives us 81, and then not forget to divide by 4, and then when x is 0 we still get 0. So therefore our e of x is 81 over 9 times 4, which is 36. So we can simplify this up a little bit. Common factors here are going to be 9. So that's going to leave us 9 over 4. So that's our mean value. So E of x equals 9 over 4. Okay. Now we're going to come back to this integral here, because now what we need to do is we need to find the variance. So the variance, got a nice formula for that along these lines here of what information we've got so far. We can say V of x equals E of x squared minus the mean squared. Now E of x squared, that's not to be mixed up with now there is a case where this may be true, but in general this doesn't mean the same statement. So E of x squared and E of x itself squared, they're not the same thing. So now we can do E of x squared, we can work that out, and then mu, which is just the mean, we know that that equals E of x. So mu squared equals E of x squared. So to find E of x squared, that's the second moment. So we can put an x squared in there and change this one here to x squared. Okay, so now we've got another integral very similar to before. 0 to 3, x to the 4 over 9 dx, and then leave that equal sign there. Okay, so let's go ahead and integrate and bring the 9 out the front. So 1 over 9, and then x to the 4 gives us x to the 5 divided by 5, 0 to 3. Okay, now 3 to the power of 5, let's just be careful here. So we've got 1 over 9, 3 to the power of 5, 3 squared is 9, so 9 squared is 81, that's 3 to the 4, so multiply 81 by 3, we get 243, divide that by 5, and then x is 0, it becomes 0. So that's our E of x squared. Let's just simplify this up a little bit. So that becomes 243, 5 9s are 45. So we can divide here by 9 by the looks of it. So divide this by 9, we get 5. 9's into this, well 180 is 20, which gives 63 remainder, so we've got 27. So make a note here, E of x squared equals 27 over 5. Okay, now we want, for the variance, E of x squared minus mu squared. So let's just take this calculation off the board. So now let's just write it here in full. V of x equals E of x squared minus the mean squared. Now we've got these numbers here already calculated previously. 27 over 5 at the second moment, E of x squared. And then the mean is 9 over 4, which we then need to square. So 9 over 4 squared. Okay, let's just go through this. 27 over 5. So this is just simple elementary mathematics. 9 squared is 81. 4 squared is 16. Now we need a common multiple in the denominator. So 5 16s are 80. Let's just go straight for 80. So that means this side multiplied by 16. 27 times 16, or 27 15s are 405, so that's 432. And then this one we've multiplied by 5, so 581's 405. So that's going to give us 27 over 80. So therefore our variance is 27 over 80. And you can simplify that up as to a decimal if you prefer. Same with this one here, the mean 9 over 4, you can put 2.25. This one as a decimal, it's going to be somewhere around a third, but I'll leave that for you to calculate. Okay.